A very warm welcome to all of you. I, Akash Sharma, on behalf of MIDAS IT, welcome you all to this webinar on tunnel, where I would be focusing mainly on MIDAS Gts Nx and its capabilities to deal with tunnel problems, and I will be giving a brief introduction about MIDAS SoilWorks capabilities to solve the same. So talking about today's workflow, first of all, I will give a brief introduction to the tunnels, the numerical analysis, and the advantages to be used while dealing with tunnel system, then simulation of the construction process and numerical modeling, the brief introduction to TBM, that is its advantages and disadvantages. Then I would be mainly focusing on today the demonstration part, right from complete modeling to results, how you can do a 3D modeling in Gts Nx, and finally we'll conclude with a brief introduction to 2D analysis. So tunnels nowadays are very important in present day, especially serving as an effective mode of transportation, being it both for roadways and railways. Now about the analysis of tunnel and why the need of numerical methods. The non-numerical ways provides good prediction of the ground response to tunneling and the loads in tunnel lining, and also they are arguably cheaper and quicker to use. Then the question arises, then why numerical analysis? First reply is the conventional solution are uncoupled in nature. For example, the loads are determined by one technique, that is the elastic solution, and the movements determined by the other, which is empirical, and hence both the results are uncoupled in nature. Now the second thing is the limited results. One obtain limited results that also considering greenfield situation with no structure or substructure to influence the pattern or magnitude of ground displacement. So this can't be considered with the non-numerical approach of tunnel analysis. So what are the advantages one get with the numerical methods are? First of all, you can simulate the construction stages, that is you can simulate the actual ground sequence in your model. Second, you can deal with the complex ground condition. You can model the realistic soil behavior. Fourthly, you can handle complex hydraulic conditions. Also, you can deal with different ground treatment, for example, the compensation grouting. Also, account for the adjacent surfaces and structures and how they are going to influence your results while dealing with tunnel analysis. Similarly, you can simulate the intermediate and the long-term conditions for the stress analysis, the displacement, and even you can do the consolidation analysis for the same, and you can deal with the multiple tunnels at a time. So these are the advantages one get when you go for the numerical method for the analysis. Now simulation of the construction process, the consideration which one should take while simulating the construction process of tunnel is, first is the type of problem. Tunnel construction is basically a 3D problem, but if you want to consider simplified analysis so as to study the effect of tunnel construction, one can proceed with the 2D analysis, considering it as a plane strain problems. Now, so we have two types of simulation. One is 2D, for which MIDAS provides with the solution SoilWorks, and the other is 3D, that is the MIDAS solution being MIDAS Gts Nx. Now secondly, the initial ground condition. Now whenever there is excavation, the loading of structure depends on the stress changes associated with the process, and it is important that these stresses are estimated accurately. So these are basically the initial ground condition. Now the third point is the modified ground condition. Now consideration of nearby structures also becomes very much important, and it do affects the stress variation and it need to be considered. For example, you can see in the figure that there was an excavation in which the initial ground condition was with the tunnels and without the tunnels. So in one excavation we did not consider any tunnels nearby, and the other we considered a tunnel. So you can see the difference in the horizontal wall displacement, and hence could affect your results considerably. Now the fourth thing which one need to consider is the boundary and loading condition. Now first is the boundary displacement conditions. So they are required to present the far field conditions or any symmetry of the problem. Similarly, we have the loading condition. they are like required to simulate various types of loading the tunnel construction is subjected to. Similarly, the consolidation condition considering the construction stage analysis and soil interface to simulate the ground condition more accurately. Moving on, next is modeling of tunnel linings. So first, the use of solid elements for the same. Now, using the solid elements to represent the tunnel lining allows the analyst a wide range of constitutive models, but a significant drawback is the need to maintain an acceptable element shape that is defined by the aspect ratio of length to width. So, a tunnel lining is likely to be very thin relative to the tunnel diameter and the boundary distance. The consequence of maintaining an acceptable aspect ratio is the need for a large number of elements. Now, the second way of modeling the tunnel lining is the use of shell elements. Using zero thickness curved shell elements to model the tunnel lining has removed the problem of aspect ratio, and their use allows more flexibility in the mesh definitions. So one should also consider the same while simulating the construction process for tunneling. Next, the most important one is suitable constitutive model. As I have already discussed in the previous webinar, the importance of different constitutive model. So one should select the suitable constitutive model to simulate the ground behavior. So which is very much important to get reliable results from the numerical modeling analysis. For example, this is from a particular project in which clay was used. So in one Moore column was used and the CAM clay model was used to simulate the situation, and you can see the difference in the displacement for both the models. So one should be very careful to choose the constitutive model while considering the numerical analysis. Now, a brief introduction to TBM. TBM, as you all know, stands for tunnel boring machine. A tunnel boring machine is a machine used to excavate tunnels with circular cross section through variety of soil and rock strata. They are used as an alternative to drilling and blasting. Now, the advantages one have with tunnel boring machine is they have this advantage of limiting the disturbance to the surrounding ground and produce a smooth tunnel wall, and this significantly reduces the cost of lining of the tunnel and makes them suitable to be used in heavily urbanized areas. Now, the disadvantage is the upfront cost, that is TBM are expensive to construct and are very difficult to transport. Now, what we get when we do for the numerical modeling for TBM, so the results which we obtain. So one who perform the numerical modeling gives you the following results to understand its effect and efficiency for any project. First is the stress strain variation in the soil mass and short creep as a result of the construction stage sequence using TBM. Second is the subsidence of the crown of the tunnel as a result of construction, thus checking its feasibility. Third is the surface displacement, and hence could be used to check the settlement or the differential settlement of nearby structures. So this is how one can proceed whether the particular or what is the effect one is going to face while going for tunnel boring machine or tunneling in a particular soil profile. So today I would more be focusing on how one can use Gts Nx for similar kind of simulation. So I'll just move on to Gts Nx. Okay, as you can all see, this is basically the interface of Gts Nx. Now, first of all, I have already defined the material property. So let us have a look at the same. So this is basically my soil model. So I have used the Moore column constitutive model, and these are my C and phi value. This is the segmental property, which I have given as elastic properties. Similarly, we have steel, that is for shielding. So I have given the steel as elastic properties. And finally, we have grout. Basically, steel and grout material properties would be used for manipulating the seal condition. First of all, we'll be using steel, and later on we'll be changing the boundary condition and changing the material properties to grout. So it will be better clear when I will be demonstrating you in the model. So let us start with the modeling part. So as you can see that the Gts Nx, we have a tabbed kind of interface. So all the different tools like the geometric modeling, all are tabbed within one tab bar. Similarly for mesh static, so one need not wonder about the software to find for various options. So let us first create a rectangle. So just click on rectangle. Okay, so we'll be creating a 2D rectangle. So let the input location be 0, 0. Now the method is absolute, so make a face. So just press enter, and next you have to input the diagonally opposite corner. So let it be 50, 50. So click OK. So you can see that the interface is created for you. So this is basically my main model of the soil. Now let us create a circle for the tunnels. So click on circle. You can see that within the point and curve you can find all the options. So click on circle. Now you have a variety of input methods. So select the first method. So first you need the input the center location. So let it be at the mid of the soil, that is 25, 25, and just check on make face. So the program will automatically create the face for your model. Press enter. Now just input the radius, that is 3.4. So just press enter. So you can see the circle is created. Now I would create another circle just for my segment formation. So the input location remains the same, but the radius increases to 3.7. Just click OK. So these are the two faces created. Now this is the workstree window with MIDAS Gts Nx. So all the geometric property, material property, whatever mesh you create comes here. So like if you want to hide, unhide anything, you can do it from here. Like these are the three surfaces we have created right now. So you can open it and you can just see it while you work. So it becomes very easy to understand what you have created. Now let us create the solid for the same. So go to protrude, and there is the option called extrude. Click on extrude. Okay, so this is extrude. Now select the target object. So I need to select all the faces which I have created. This is the selection filter. So whatever you want to select, you have to make sure that it is the option is checked for that particular thing. Like we have to select the face right now. So select all. Now in which direction you want to extrude, so just click on that particular axis, or you can also define it using the 2 points vector. So in this case it's very simple, and the length, let's say, be 20 meters. So you can just preview it, so it looks fine, and just click OK. Now you can see that we have three solids created. You can just unhide the faces. So this is my main ground. So you can just press F2 and write the name as ground. Similarly, you can see that this is my inner solid. Now all of you know that whenever we are dealing with solid geometry, the co-phase generation becomes a very important function for proper mesh nodal connectivity afterwards. Now Gts Nx provides with the option called auto connect, which you can find in surface and solid. Just click on that. So you can see that auto connect. Now you just need to select all the solids and just click OK. And what the program will do is that the program will automatically generate the co-phase between the solid. So you need not operate the Boolean operations again and again for the co-phase generation. So this is my ground. Now you can see this is my inner circle. So just I will write it as inner circle. And this is my external circle. You can see. So just press F2 and write the name as external circle. So press enter. So these are basically the three solids which we have created. Now next is since we would be excavating it in stages, so what we need to is we need to divide the tunnel which we are going to create into different solids so that a different mesh set will be created, and then you can use it in the construction stage analysis. So just go to the front view and just click on the rectangle. So you can create a rectangle which is covering both the circles for the tunnels, and just click OK. So I'll just Control Z. I'll just make the face also here itself. So just click on the two opposite corners and the surface is created for you. Now next thing is we'll be using this face as a dividing tool. So what we'll be doing is that we'll be transforming it in the direction. So let us just uncheck the solids. So you can see this is the face which I have created. So you can go to transform and there you find the option translate. In the translate option, select the target object which is our face, select the direction in which you want to translate, make a uniform copy. Let's say we need at a distance of 1 till 19 meters. So just preview it and just click OK. So this is my rectangle with all the tool surfaces. So I'll just delete the first surface because we don't want it to be used as the dividing tool. Now we'll divide the tunnels using these surfaces. So as I've already said that whatever you create, it comes in here. So go to divide in solid. Now select the target solids. So this is the selection filter, that is select all, unselect all. So if you select all, both the solids, that is both the tunnel parts, the external and internal, will be created. Now next we have to select the tool surfaces. So what you can do is you can just uncheck the solids and then you can use the option select all. So all the surfaces which were visible on the screen would be automatically considered. And now if you want to divide the touching face of the main solid, you can use the option, just click on ground, select that ground, and you can just click OK. So now you can see that the tunnel is divided into 1 meter segment each. So now we can proceed with the rest of the modeling. So we have almost completed the solid modeling right now. So now let us start with the meshing part. Okay, so these are the various solids created. So what we can do is you can just click on the solid and sort by name so that the selection becomes easy. So I will unselect all, and first of all let us select the external solids. Okay, so these are the external solids for me. So go to mesh, there you can find the option 3D mesh. The 3D mesh, what you can do is you need to select the object. So that's why I've activated only the external solid. So just select all and let the size being 1. The measure which we'll be using is the hybrid measure, and the property, let's say, being of soil initially. So external soil, let's say, and just click apply. Okay, now it is being meshed for you. Similarly, now we'll activate all the inner circles. So just select all the inner circles. Okay, now from the mesh you can unhide the mesh which was created. Now select all. Same, the remains same, just the mesh set name being, let's say, inner soil, and just click apply. So you can see in the mesh set that they have been created with the name, and finally we would mesh the solid. So once again you can uncheck the mesh set and just select the ground and select that particular ground, let the size being 4 and let the name being ground for the main ground, and just click OK. So the program has meshed everything for you. Just allow me to activate all the mesh sheets so you can see all the mesh sheets. Now if you go to the tools, there is check mesh quality, and in the check mesh quality, in the feature, you can find the free faces. So when you click apply, see, there shouldn't be anything cumbersome in between the model except for the free faces of the outer surfaces. So the meshing is fine. That is, there is proper nodal connectivity within the model. Okay. Now, as I was discussing, next thing is we have to generate the seal elements. So what I will do is that I will just activate all the solid external circles. So these are basically my external circles. Now what I would be doing is that I would be extracting my seal using the faces of this external circles. So go to mesh, there you can find the option extract. Now in the extract element function, in the geometry you can change it to face. So select all, skip duplicate images. The property now is being of steel initially, and I would be showing you how it would be changing it during the construction stage using the change boundary condition, and register based on the owner shape and the name being shield. So just click OK. Now just unhide all the solids which you have created. So this is created. Now as you can see, there are few things which you need to be deleted. That is the thickness, because we don't want the shield to have any thickness. So go to front view. Now in the same mesh, you can see in the element there is option delete. Now the type of selection you want to do, you can change it from this option pick. So there, this is singular one, and I would go for the polygonal select right now. So just select the inner object, so whatever comes in between it will automatically delete. And just you can select and then delete. OK. Now you can go to the side view, once again use the delete command and select the outer thickness area. Just change the once again the selection to select by single, and you can just select the outer thickness area, which I will be showing you after delete how it look like. So click OK, and now you can see that it's a thin shell element constructed for you. Now the next most important thing while considering the construction stage analysis is the naming, and that it should be properly named so that whenever you want to use it, you need not check whether it is properly named or not. So MIDAS Gts Nx provides with a very advanced option. So just select all the seals. So these are the seals. Now I want my first seal as seal 1, 2, 3, 4. So what you can go, you can just to assure that it's named correctly, just go to mesh sheet, rename. In the rename option, just select all, and you can just change it to y-axis for this direction, that is 1, 2, 3, 4, and this direction it should be. Mesh sheet name, so you should clearly define a well standard mesh sheet name so that you can use the construction stage wizard available with MIDAS Gts Nx. So seal 1 and just click OK. Now to check, you can just check. What I would be doing is that I will just sort it by name. Okay. Now you can see the seals which are created. Now this is one, and as I go on, it changes. So everything is fine. So similarly, you need to define it for others. So just check on first of all the external solids. So you can see that how the workstream becomes a very important to simulate such complex models. So once again, rename, select all, the first axis we make it Y, the name being as external circle, let's say, and let us give it a hashtag and just click OK. Now similarly, we have to do it for the internal circles or the inner soils. So just select it, I'm sorry, So just select the inner solid. You can use the shift button for the same. Okay, so these are basically, once again, rename, select all in the Y direction. Let's say it be the inner soil, and hash, and just click OK. So we are done with the renaming part. Now the next important thing is the loading conditions. Now as you know that various kinds of loads are considered whenever we are dealing with tunnel. So I will be showing you like how to consider few of them. So let us start. First of all, let us go to solid. In the solid, we'll first of all activate the inner circles. So let us first start with the self weight. This is my whole model, and so let us go to static slope analysis. First load we'll define is the self weight. So in which you can just give it a name. Let's say SW. GZ direction will be the direction of the gravity, and just click OK. So the self weight for the tunnel has been created. Now the next few of the loads which I would be considering is like the hydraulic pressure, the jack thrust, the segment pressure, the external pressure, and I'll be showing you how easy it is to work on when you are dealing with NX. So let me just expand this window for you. Okay, so I will just select few of the inner circles, like 3, all the odd inner circles. So that is why we have named it. So I'll just be showing you that how can you consider the various pressure, 13, 15, 17 and 19. So you can go to the side view. So these are basically the inner circles. Now whenever you want to consider, let's say, hydraulic pressure, so you know that hydraulic pressure is given to this face so that you can so as to resist the pressure from the forward direction. So just go to pressure. In the pressure, in the object type, make it face, because we are dealing with the solid elements right now. Select the object. So you can just select the face, and the type, let's say, changes to reference axis, and the reference axis being Y for this direction, and let the load being, let's say, 200 kilonewton per meter square. You can just preview it, and you can just give it a name, let's say HP1 for hydraulic pressure, and just click apply. Similarly, you can select the second phase, you can just give it the name HP2, apply, so on and so forth. Just to save time, I will show you the rest of the loadings. Now what you can do is that you can just uncheck all the solids, and now you'd be applying the jack thrust forces. So you can just select few of the 2, 4, 6, 8, 10. That's it, just for an example. In the side view options, you can see it more clearly. Now jack thrust would be acting on this face in opposite direction. So the pressure, this is the pressure. So once again, change it to face, select the object. So this is the face this time. Once again, change the type to reference axis. Y axis will be our reference coordinate system, and the force, let's say, minus 4,500, and the force being J1 for jack thrust 1. You can just preview it, and you can see the direction in which it is working. So you can consider a similar kind of pressure. So just click apply. So this is the second type of load. Now if you want to consider the segmental pressure load on the external solids, what you can do is that you can consider the same. Just uncheck. Let's say we'll just select all the external solids. So these are basically my external solids. Now if you want to consider the segmental pressure, now it also depends that how many segments which you are creating in a single go. So let's suppose you want to consider pressure. So once again, the pressure load you are going to apply, you will select that face. So let's suppose I am considering 2 at a single go. So just change the opposite direction. So segmental pressure. So you can just let it be normal and let the value be let's say 50 kilonewton per meter square, and let be S1 standing for segmental pressure. Okay, so let it be S1. So you can just select once again face, the two faces. So these are basically the rotation view options available with us. You can just preview that which direction it is working on. So let us give a value first, let it be 50. Now you can proceed with S1. Similarly, this one is like apply for S1, and similarly if you want to apply the external pressure loads on this external circles, you can apply it here itself. Let's say 1000, and you can give the value as E1. So similarly, this is, I'm just showing you for one portion. So you need to select it once again, and just can just preview it. These are basically my faces. So I'm just showing you for one portion. So for complete modeling, you need to define it for each of the section which you have created, like HP1 up to HP5, 6, whatever your number of sections are, and similarly jack thrust 1 to whatever the numbers you have considered. So similarly, you have to create the different loadings. Now the next is the boundary conditions. Now for boundary conditions, first is the external boundary conditions which you need to apply. So this is basically my meshed model. So in static slope static analysis, in the constraint, you can find that you have three options: basic, which basically stands for fixed paint and no rotation, which we use commonly. Second is advanced, and third is auto. So auto is a function which automatically generates the surface for the model, the boundary condition for the model. Just click OK. So you can see that it is automatically creating the boundary conditions for the model. So you can also consider manual boundary conditions. If you want to consider, you can go to the advanced option, and you can restrain any particular degree of freedom as per your consideration. So we have created the first boundary condition. Now the second most important thing is, as you know that when we started on the external circle which we are going to be using as a segment has the ground material properties, because at the time of meshing we have used the ground material properties. Now later at the stage when we goes on activating or deactivating the solid elements, that is we go on with excavation, what happens is that we convert this segment element or this sealed elements into a different material property. Now to consider that, MIDAS Gts Nx provides with the option called change property. So let me show you. So this is the change property option. So first of all, let's talk about only the external circle. That is, we'll just select the external mesh sets. So these are basically our external mesh sets. So in the analysis, you can just uncheck the boundary condition for now. So these are my external mesh set. Now you can see we'll select it, and we'll change the property to segment at a later stage of the construction stage, and let the name being segment change or property change 1, and you can just click apply. Now you can see that in the boundary condition automatically change property boundary condition has been created. Now whenever you want to activate it, whenever you activate it, that particular mesh sets which is activated in that construction stage gets the property not of soil, but it now is of the elastic property, as I have shown you earlier during the webinar. Similarly, what you can do is that for the steel, as you know, initially we have given the property of steel. Now as the construction completes, what we do is that we give it the property of grouting, that is concrete, which we have already defined. So just select the sealed, just select all the seals. So this is my seal. Now once again, change property. Now in the construction stage, you can select all the objects, select all. Now the property changes to grout, and you can just click OK. And just what you need to do is you need to activate that particular boundary condition. later on. So now, just to save time, what I'll be doing is I'll just open a file in which we have already defined the construction stage. Okay, now before moving on to the construction stage definition, I would like to show you the stage wizard available with MIDAS Gts Nx, which becomes helpful in case you are dealing with such complex geometries. So as you can see that there are first the set type, that is you are dealing with mesh set, boundary set or load set, whichever set. So that is why at the time of naming I was giving too much concern about how my naming should be in proper direction so that I can use my construction stage wizard. Next is the set name prefix, whichever you want to give, like that is I have named it. You can see external circle, ground circle, internal circle shield. So you have just to input the post processing unit, that is 1, 2, 3 or the other. Now A and R stands for select whether to add or remove a selected set. So when A is displayed in green and R is displayed in yellow, so that is for selection and removal. Start postfix is like specify the set number of the selected set that is used first in the construction stage. Like for example, if a mesh set specified from, let's say, final core 1 to 12 is selected and the final core is removed at the second construction stage, now with the other cores removed in sequence after each step. Now the first used set number is 001, so the postfix can be set as 1. So that is what it means. Now F is basically to check this option only when the selected set is not used until the final number. So the user can input the end suffix when checked if it is not checked. The set is usually sequentially until the final number, so you can find the details more. So end postfix and postfix increment remains the same, the start stage and the start increment. So you just need to define all these properties for all the mesh set and click apply the assignment rules, and automatically the program will define the construction stage for you. So just to show you the stage, I will just simulate the stage. So you can see first the construction stage goes on. Just change it to the front view. So these are basically my construction stage, and to see in detail you can go to stage set. And also if you are uncomfortable using the stage wizard, what you can do is you can just activate deactivate things. Like this is the initial ground condition, so activate all the ground with the boundary condition and the self weight. Now they have the ground condition. Now then you can excavate the external 1, external 2, that is we are going for 2 meter excavation per stage. And similarly now you can activate the loads too, so you can see the loads. And similarly when you go to the third stage, you excavate the third and fourth and deactivate the external mesh sets, and similarly so and so forth. Now you can see now the boundary condition for the external circle has been used to change it to concrete. So after like third excavation we are changing it and applying the various loads for the same. So you can see the various sequences, and finally you can see here the sealed boundary condition has been used where the steel has been now removed with the concrete properties. So it is that easy to deal with the problem. So hence we have completed the model. Next you need to do is just go to analysis case, go to general and define a construction stage for the same, and in the analysis control you can consider the various options. Like if you want to automatically consider the water pressure even there is no mesh set and you have defined a water level, you can check it for the same. To simulate a condition, what would be a better example of like swimming pool construction? Similarly the non-linear parameters and the contact data. So now I will just move on to the post-processing part. Okay, so now you can see that in the post-processing part what results you get. Just a second, we'll just go to results. So you can see the various results which you obtain as a result of the same. So if you want to like extract the values, just a second, I'll be just opening the model. There is, okay, here it is. Yep. So these are the various results which you obtain, like for the first excavation. So what are the displacement in the Tx, Ty and Tz direction, and similarly at various stages what are the various options you obtain. Let me show you. Like you want to just activate the sealed elements so that it will be more clear. Now if you want to see that what are the member forces and that are coming as a result of the first construction stage on the seal, so you can check that also. And let's go to the last construction stage. So you can see the cell element forces because we have used. So what are the member forces which you are obtaining? So you obtain the various displacement, the grid forces, reactions like cell element forces which are there in the cell as a result of the construction stage sequence, the solid stresses in the soil. So just I will check the model, full model. So what are the solid stresses which you are obtaining as a result of the seam in the XX direction, YY direction, ZZ direction, and similarly the solid strains and all. So these are the various results. Now to how to extract the results from a continuum model is a very important thing. I would like to discuss few of the tools in here. For example, first one is the probe. So let us talk about the displacement. So first one is the probe. You can see in the advanced options. With the probe, whenever you click on a particular node, it gives you the value for that particular option which you have selected. Also, if you want to see where is the maximum and where is the minimum value, you can directly check in from there. Also, like if you want to extract, like we have a 19 stage construction stage sequence. So this is my analysis. Let's say TZ direction. And I want to check how this particular point, that is the top point or the surface, is going to behave as a result of seam. So you can just click on table and you get an option directly where you can see and you can directly export it to Excel for further reference or graph preparations. So this is the second option of extraction of result. And now moving on to the presentations. So you have seen like the post-processing results. The most important for like tunnel boring machine is, let's suppose you have a structure above, but please do consider the fact that if you have a structure, you have to initialize the stress condition or consider the modified ground condition whenever you are considering the nearby structure. So just for an example, in the same model, let's suppose you are considering two nodes which are 11.5 meter and you want to check how the construction stage sequence is going to or the differential settlement which are happening at these 2 points. So you can see that you can just plot a graph and you can see that how much the displacement is happening. So you can consider like if there are two columns, how much settlement building is going to suffer as a result of the tunnel construction. So effect of tunneling on nearby structure. Second is displacement of the top of tunnel over construction of tunnel. So you can just select that particular tunnel and see that whatever sequence you are following, whatever ground conditions you have taken, and how the displacement of the top of tunnel is going to take place over the construction of the tunnel. Next important thing is the forces or the stresses on the lining with the construction stage. As I've already shown that since you define it as a cell element, you get the forces in the XXYY direction. The fourth most important thing is the stress changes in the soil segment as a result of tunneling. So you could consider the same. Now this was about the complete 3D analysis of a tunnel. Now next, moving on for a 2D analysis of structure, as I already discussed, like tunnel excavation are mostly 3D problems, but in case of a plane strain problems where you just want to simplify your analysis, one can consider a 2D analysis to study the influence of tunneling. So just to show you, I'll just open model in SoilWorks, which is the 2D solution of MIDAS. So I'll just show you the construction stage definition which we are using. So first is the original data. So you can see that this is the original ground condition. I'll just minimize this window a bit. Okay. Now the second is the installation of structures. That is, you can see that buildings have been initialized, and you should consider the fact that this condition, the initialization of ground condition, is very much important to study the influence, because whenever a structure is created, it is going to affect the stress variation in the model. So you can consider the same. Now next, the upper tunnel excavation. So the same. Then installation of the upper reinforcement. So you can see that the reinforcement. Similarly, the lower tunnel excavation, the installation of the lower reinforcement, and the curved, the lower reinforcement. So these are basically a 2D plane strain problems which you can consider, and you can just run the analysis and get the results and study the effects of the same for the same. For example, again I will just go to the last, and you can see the horizontal displacement and the vertical displacement which is going to affect. So you can see, or you can study the effect on the nearby buildings or nearby pipes as a result of the tunnel construction. Similarly, you can, like since we have been going for the embedded truss for the nails, so you can also find the forces, the X and Y direction. So just before I end, I would just like to summarize today what we have learned. So today we have learned the basic importance of numerical modeling. What are the advantages of using numerical modeling, about 2D analysis and 3D analysis, and how one should proceed with the construction stage definition for a model like TBM, and consider the analysis and get the post-processing results which are important for you. So with this, I would thank you all for joining this webinar, and on behalf of MIDAS IT, I would end this geotechnical webinar series. Hope this was very much useful for all of you, and like if you have any further queries, you can contact us at techsupport@midasit.com. So thank you very much to you all. Thank you.